Alright, welcome guys. Okay, so today's lecture, let me just or video, not lecture, just for fun. So introduction to skins. Okay, so these small videos, I just want to talk about the definition of the affine skin. Okay, so this is very interesting. I mean, okay, so A is a commutative ring with identity. Okay, so then we can define a spec A. So spec A basically is P right in A, and P is a prime ideal. So you take all the prime ideal of A, right, and forms a set. Okay, so we want to view spec A as a topological space. Okay. Not only that, we will see that we will attach a sheaf on it. Okay, so basically spec A is a topological space. So basically we want to give an open set, right? Give an open set. Okay, so or the open, I should say the basis. Okay, so for f belongs to A, I can define this df, right? So this df is just df is a set. Df is a points, right, in the spec A. So the points in the spec A is a prime ideal in the of a spec of A, right? So df should be defined to be such p such that f do not belongs to p. Okay. So this is very easy, right? Because f is an element of ring, but p is a prime ideal, right? So it's obviously that one can talk about f belongs or p or not. Okay. There's also another definition say that f of p is non-zero, right? But this requires more definition of what is f of p, right? Because now pre is a prime ideal, right? So and f is an element of a ring. So actually, yeah, I mean one can define this by yeah, I mean, okay, I will say that later. Okay, so df is called a distinguished open set. Okay, so basically, the idea is that df forms an open set. I should say forms an open basis of spec A, and this is easy to prove because right, A is quasi compact, right? So if one can write A as this, then one can easily prove that spec A is basically the union of Fi. Okay, so the next which is the great invention is the sheaf, right? So there's a structure sheaf on the spec A. So it depends on how you define the structure sheaf, right? But the standard Grothendieck definition, which is very amusing. I mean, yeah, from my own perspective, is OX. Right. So basically, for OX, okay, I should say spec is X is spec A, right? So for each open set, right, you need to define you need to give a sheaf. So always a sheaf of ring. Basically, for each open set, you need to give a ring and satisfy the sheaf property, which is hard to prove, right? But usually, yeah. So the proof can be seen the hard shown, right? So this OX, I only need to define it on DF. It's already enough, right? So I need to give a ring structure on it. Let's say AF. Okay, so AF means there is a localization at F. So this is the localization of ring. So let's the easiest, maybe you just written as y divided by f of n, which y just belongs to A. Right. So this is a very I mean the algebraic definition is just this. Okay. And right. So this is so once you define each OX at the open set, right? Then this OX is uniquely determined. This can be proved for any kind of space. Once you given OX on the open basis, then all the other are fixed. Not only that, if you take a stocks, so this is a stocks, right? Basically, if you learn about sheaf, then you can talk about stocks. So the stocks of point P at so now P is a prime idea, right? So it's just a localization and P. A localization is basically x divided by y, which I think y do not belongs to P, and x belongs to P. Sorry, x belongs to A. Okay, so this is the AP. Okay, and this is the so if given a spec A, and that kind of structure spec A, it's called a affine scheme. So any space, I mean any like a local ring space, for given a space OX, right? For given a space X, underlying topological space X, and the structure sheaf OX on X. If OX, if they're isomorphic to this space, then it's called a affine scheme. Okay, and the general scheme. Okay, so the general scheme. So this is the definition of scheme. So given X, which is the underlying topological space, and OX, which is basically it's local ring space, local ring. So basically, for each open set, it gives you open ring. If this general scheme means that is this open cover UI. Yeah. So basically, X can be written as UI, right? So this is just on topological space. But at each UI, right? So if you restrict X to each UI, then it becomes another local ring space. For each UI is isomorphic to some there's AI, right? There's AI such that this UI basically is spec AI, or spec AI. So the general scheme, can be viewed as locally affine scheme. Okay, so this is the definition. So more general, so you can view that as the manifold, right? So basically, the manifold is the smooth manifold looks like at each local. So at each point, locally looks like the Euclidean space, right? So we need to use the open set language to define, but intuitively, that's it. Right, but for the general scheme, we need to define a affine scheme, and there's a UI, right? There's open cover that of X that which if you restrict each UI, right? Each UI looks a spec AI and looks like a spectrum of the commutative ring with identity. Okay, so the key is that okay, so there is a subtlety there here is that so there's just small remark. So not all open set in affine scheme. So what am I saying that if somebody give you a affine scheme, right, and then you take an open set of affine scheme, it's affine, right? But this is not wrong, right? Not all open sets, I should say, now open subsets in affine scheme is affine. Right, and the reason is that the small example is that you take a field K, and then you can ask about spec K as Y, right? So this is the affine plane, right? Affine plane. And then you can, if you remove the origin, right? If you remove the origin, then this origin corresponding to this origin is a close point, right? Because it corresponding to the only if it corresponding to the maximum idea of this I should say the maximum idea of this polynomial ring, right? So the AK the affine plane remove the origin isomorphic it's not affine, right? Basically it's like this one is like a projective space, right? Since you move the origin, it's not affine. But this is definitely the open in the affine plane. Okay, so I think this is a general starting point of the algebraic geometry. Just quickly introduce the scheme, and yeah, and also yeah, that's it, right? And basically, if one has a affine scheme, right, one can define there is a notion called a quasi-coherent sheaf. cosine coefficient shift on a spec A, right? But this is much difficult to define, so maybe we will leave next time if I have a chance. Okay, I will see you guys in the next videos.